In this video, we will learn how to solve an initial value problem with distinct real roots. So we have 3 cases in this section. So that's kind of our first case. So we should be familiar with the second order linear homogeneous differential equation, and you have double prime, prime, and the function itself, and you know the value at 0 and the first derivative at 0. So we know we will start with this second degree equation. Kind of you just put the coefficient in front. And then this one, it's easy to factorize. But if not, you just use the quadratic formula. So R1 is 6, R2 is -3. And then we write down the general solution. You should have seen the derivation once in the lecture notes, but at this point we're just going to memorize how to write down the general solution. It's it's kind of the 2 exponentials, right? And then you put the roots as the coefficient of the exponent, and then don't forget that since we're talking about general solution, so you should allow kind of the linear combination of that. So you put coefficients C1 and C2. But then since you are given initial conditions, right? So then you can solve for the C1 and C2. So if you think about it, you have C1 and C2 as kind of unknown, but then you have kind of 2 pieces of information, so each of them will give 1 equation. So then at the end, you can expect that 2 equations will solve for 2 variables, C1 and C2. So that's the plan. So if you plug in t equals 0, y equals 0, we get C1 plus C2 equals 0. And I want to kind of put a note here, which is, I know a lot of people will make this mistake. Be careful that e to the 0 is 1, not 0. That's something people always kind of forget. So e to the 0 is 1. That's why you have C1 and C2, because these 2 both become 1. And then to use the second initial condition, we need to take the derivative, right? So we have the general solution here. So taking derivative is going to give us, you just pull out the coefficient, right? So 6C1, and then pull out the -3, -3C2. I forgot to write the exponential. So e to the 6t and e to the -3t. Right? So that's the first derivative, and then you can plug in the 0. So then it's just 6C1 minus 3C2, which equals 4. And then you can solve, C1 and C2 fairly easily. So I'm just going to tell you that C1 is 4 over 9. C2 is -4 over 9. So then you should make a conclusion that the solution is, now we know the C1, C2. So 4 over 9, and then -4 over 9. Okay, so I think the only place where people tend to make mistake is this thing, e to the 0 is 1, and then you should and then you need to know how to use this second condition, which is you need to take a derivative take derivative of the general solution, and then plug in t equals 0. That's how you get the second equation. Okay.